1945. Germany. General Dwight Eisenhower stands on the Autobahn watching military convoys move at speeds impossible on American roads. The concrete stretches to the horizon, perfectly straight, perfectly flat, 4 lanes wide with gentle curves and grades that let trucks maintain speed even through hilly terrain. No stoplights, no intersections, no towns to slow for. Just uninterrupted movement at 60 miles per hour. Eisenhower has spent the war moving armies across Europe, and he's learned that logistics wins wars. Mobility wins wars. The ability to move men, equipment, and supplies faster than your enemy can react, that's the advantage that ends conflicts. But he's also seen what happens when logistics fails. The memory is vivid because it shaped his entire career. 1919. Lieutenant Colonel Eisenhower, age 28, volunteered for the U.S. World Army's Transcontinental Motor Convoy, a publicity exercise designed to demonstrate military readiness by driving a convoy of trucks, cars, and equipment from Washington, D.C. to San Francisco. The trip took 62 days. 62 days to cross a continent. Vehicles broke down daily, engines overheating, transmissions failing, wheels shattering on rutted roads. Roads turned to mud when it rained, trapping trucks for days. Bridges collapsed under military weight. The convoy had to detour hundreds of miles to find river crossings that could handle the load. They averaged 58 miles per day. Some days they made 5 miles. Some days they didn't move at all. Eisenhower filed official reports documenting every failure, every delay, every inadequacy of America's road system. Those reports gathered dust in War Department files for 37 years. Standing on the Autobahn in 1945, those memories return with force. Eisenhower understands viscerally what America needs. Not for war, the war is ending, for prosperity, for commerce, for national unity. A highway system that connects the country the way the Autobahn connects Germany. What he doesn't know yet is that the machines required to build 46,876 miles of interstate highway don't exist. The earth-moving equipment, the concrete pavers, the haulers, none of it operates at the scale required. They'll have to be invented, and they'll have to be invented fast. This is the story of the equipment that built the interstate highway system, the largest construction project in human history, and how it almost didn't happen because nobody knew how to move that much earth. The Federal Aid Highway Act of 1956 authorized $25 billion for interstate construction, roughly $270 billion in today's currency. The final system would cost $114 billion by completion in 1992, over $530 billion adjusted for inflation. The scale was unprecedented. 46,876 miles of controlled access highway connecting every major city in America. 4 lanes minimum, 6 or 8 through urban areas. Grades limited to 3% maximum. Curves designed for 70 mile-per-hour travel. Exit ramps every few miles. The engineering standards were German Autobahn specifications adapted for American distances. But specifications don't move dirt. Machines move dirt. And in 1956, the machines that could build interstates at the required speed and scale barely existed. The challenge was earth moving. Every mile of interstate required moving approximately 1 million cubic yards of earth, excavating cuts, building embankments, creating the precisely graded roadbed that would support concrete or asphalt. Multiply that by 46,876 miles, and you get 46 billion cubic yards of earth that needed to be cut, loaded, hauled, and placed. To put that in perspective, the Panama Canal required moving roughly 200 million cubic yards. The interstate highway system required 230 times more earth moving than the Panama Canal, and it needed to happen in 35 years, not the century canal engineers originally estimated. R.G. Letourneau had been solving earth-moving problems since the 1920s. Robert Gilmore Letourneau was born in Vermont in 1888, educated through 8th grade, and trained as an automobile mechanic before finding his calling in heavy equipment. He started building earth-moving machinery in Stockton, California during the Depression, initially manufacturing equipment for dam construction and agricultural leveling. His innovation was understanding that moving earth wasn't about strength. It was about geometry, leverage, and volume. Traditional dump trucks required loading with shovels or small steam shovels, driving to the dump site, manually dumping, and returning empty. The round trip might take an hour. Letourneau saw the inefficiency and designed something better. His invention was the scraper, a machine that could cut, load, haul, and spread earth in continuous operation. The first Letourneau scraper, built in 1922, was a horse-drawn implement with a cutting blade that filled a bowl as it was dragged through soil. The horse provided power. Gravity and clever geometry did the work. By the 1930s, Letourneau was building motorized scrapers pulled by Caterpillar tractors. His Model G scraper, introduced in 1938, could move 20 cubic yards per load. By the 1950s, his designs had evolved into self-propelled units with onboard engines that could move 40 cubic yards. A single operator with a Le Tourneau scraper could do the work of 50 men with wheelbarrows and shovels, and could do it faster, more accurately, and with less physical strain. The interstate highway system would deploy thousands of them. Le Tourneau's company, R.G. Le Tourneau Incorporated, held over 300 patents on earth-moving equipment by the time interstate construction began. He pioneered electric wheel drive systems, rubber-tired scrapers, and the elevating scraper that could load itself without a push tractor. His philosophy was simple. Any task done by human muscle and hand tools could be done better by a machine designed specifically for that task. By 1956, Le Tourneau scrapers were standard equipment on every large earth-moving project in America. The interstate highway system was exactly the kind of challenge Le Tourneau had been preparing for his entire career. The scraper worked through elegant simplicity. A curved steel blade, the bowl, lowered into the ground as the machine moved forward. Earth flowed into the bowl like water into a bucket. Once full, the bowl lifted, and the machine hauled its load to the fill area. Lower the bowl, engage the ejector blade, and the earth spreads in a controlled layer. Then return to the cut and repeat. A skilled operator could cut, load, haul, and spread a load every 12 minutes. Work a 10-hour shift and move 200 cubic yards. Put 20 scrapers on a mile-long segment, and you could move 4,000 cubic yards per day. The interstate highway system required coordination of hundreds of scrapers working simultaneously across multiple states. But scrapers needed ground prepared by dozers. The Caterpillar D9, introduced in 1956, the same year as the Highway Act, became the standard for interstate clearing and rough grading. The D9 weighed 50 tons, its blade stretched 12 feet wide. The diesel engine produced 285 horsepower, delivered through steel tracks that distributed weight over 12 feet of contact length. This meant the D9 could push through forests, clear stumps, rip rock, and establish the rough grade that scrapers would refine. The D9's blade could tilt, angle, and pivot, allowing the operator to shape terrain with precision measured in inches over distances of hundreds of feet. Operating a D9 was physical work disguised as machine operation. The controls were mechanical, steel cables and hydraulic rams connecting the cab to the blade. The operator sat exposed to sun, rain, dust, and noise. The diesel engine roared 6 feet behind your head. The tracks clattered over rocks. The transmission whined under load. In summer, cab temperatures exceeded 110 degrees. In winter, you worked in freezing wind. The job required constant attention, reading the ground ahead, adjusting blade angle for optimal cutting, maintaining forward momentum without bogging down. A good D9 operator could clear and rough grade a mile of interstate right-of-way in 2 weeks. The interstate highway system would employ thousands of D9 operators working simultaneously from Maine to California. Hauling required trucks that could handle loads no highway truck could carry. Euclid's haul pack, introduced in 1957, created the off-highway hauler category. These weren't trucks. They were mobile platforms designed to carry 50 tons of earth or rock through terrain no paved road reached. The haul pack had 4 wheels, each one 6 feet tall. The frame was welded steel strong enough to handle impacts from boulders dropped from loader buckets. The dump bed lifted hydraulically, tilting 45 degrees to empty loads in seconds. Top speed was maybe 30 miles per hour on flat ground, but speed wasn't the point. Capacity was the point. A haul pack could move 50 tons per trip, run them in continuous rotation, loading from excavators, hauling to fill areas, returning empty, and a fleet of 10 haul packs could move 2,000 tons per day. The concrete itself required mobile factories. Traditional concrete plants were stationary facilities where trucks would load and haul wet concrete to the job site. This worked for buildings. It didn't work for highways that stretched hundreds of miles through rural areas. The solution was the mobile batch plant, a complete concrete production facility mounted on wheels or skids, capable of being moved every few weeks as construction advanced. These plants could produce 200 cubic yards of concrete per hour. Mix specifications varied by location. Aggregate from local quarries, cement delivered by rail, water from whatever source was available. The concrete had to meet precise strength and workability standards. Too stiff, and it wouldn't flow properly. Too wet, and it wouldn't gain sufficient strength. The batch plant operators were chemists as much as equipment operators. Placing concrete required precision machinery that didn't exist until the interstate era. The slip-form paver, perfected in the late 1950s, revolutionized concrete highway construction. Traditional concrete paving required building wooden forms, pouring concrete between the forms, finishing the surface by hand, waiting for the concrete to cure, and removing the forms. A crew could pour maybe 500 feet per day. The slip-form paver eliminated the forms entirely. The machine carries steel molds that shape the edges of the pavement. Concrete is poured into the paver from trucks. The paver spreads, vibrates, and finishes the concrete in one continuous pass, then moves forward. And the molds, the forms, slip forward with the machine, never stopping. A slip-form paver could pour 1,000 feet per day at widths up to 24 feet. The machine required a crew of 15, paver operator, concrete finishers, grade checkers, truck spotters, and laborers. If stories like this move you, if you want to understand the machines and engineering that built modern America, consider subscribing. We explore the industrial history most people never see. The human cost was substantial but poorly documented. Federal construction records from the Interstate era list 278 worker deaths directly attributed to highway construction between 1956 and 1970. This number is certainly low. State records are incomplete. Contractors weren't required to report injuries that didn't result in immediate hospitalization. Deaths from long-term exposure, silicosis from concrete dust, hearing loss from equipment noise, back injuries from chronic vibration exposure don't appear in construction death tolls, and the number doesn't count indirect deaths. Heart attacks from heat exhaustion in 110-degree cab temperatures, traffic accidents driving to and from remote job sites on two-lane roads at dawn and dusk, equipment failures that crushed or buried men working below grade. The machines themselves created new categories of danger that existing safety regulations didn't address. Scraper bowls held 40 cubic yards, 54,000 pounds of earth suspended on hydraulic rams. When rams failed, that load dropped without warning onto the operator or workers nearby. Dozer blades were controlled by steel cables under tension that could exceed 10,000 pounds. Snap a cable under load and it became a whip moving faster than the eye could track, capable of cutting a man in half. Haul pack brakes were designed for level ground. On 6% grades with 50 tons of dirt in the bed, brake failure meant 100,000 pounds of truck and earth accelerating downhill with no way to stop. Drivers learned to gear down and use engine braking, but that didn't always work. Runaway truck ramps wouldn't be mandated for another decade. Concrete batch plants used rotating drums that could catch clothing or limbs. The drums were open-topped for loading aggregate, and workers would climb onto the platform to clear jams or add materials. If you slipped, if the platform was wet from rain or spilled concrete, if you lost your balance, the drum didn't stop. It would pull you in and keep rotating. Slip-form pavers moved slowly but inexorably, maybe 5 feet per minute, pushing 8,000 pounds of wet concrete in front of a steel form. Step in front of one because you were checking grade or clearing debris, and it would push you down and roll over you before anyone could stop it. The emergency shutoff was back at the operator's station, 30 feet behind the mold. By the time someone reached it, the paver had traveled another 10 feet. Safety equipment in the 1960s consisted of hard hats and steel-toed boots. Period photographs show workers in t-shirts and jeans operating equipment without hearing protection, without dust masks, without safety harnesses, without any of the protections we consider basic today. OSHA wouldn't be established until 1970. Before then, workplace safety was the contractor's discretion. Some contractors valued worker safety. Most valued speed. The interstate highway system was built on aggressive schedules with financial penalties for delays. Contractors who finished early got bonuses. Contractors who fell behind lost money. The incentive structure rewarded risk-taking, not caution. The peak construction years, 1960 through 1972, saw 16,000 miles of interstate opened. That's over 1,300 miles per year, 25 miles per week, nearly 4 miles per day, averaged across the entire system. Achieving this required coordination of contractors, equipment, and workers across hundreds of simultaneous construction sites spanning from Maine to California, from Michigan to Texas. At any given moment during peak construction, approximately 50,000 workers were employed on interstate projects nationwide. They worked 10-hour days and 6 days per week during construction season. Concrete can't be poured below freezing temperatures, so northern states worked compressed schedules. Start in April when frost left the ground, finish in November before first hard freeze, lay everyone off for winter. Southern and southwestern states worked year-round, but dealt with heat that made concrete finishing particularly challenging. Concrete hydrates through chemical reaction, and that reaction accelerates in heat. Pour concrete at 95 degrees, and you had maybe 90 minutes before it started setting. Work had to proceed quickly, precisely, and without error. The equipment itself required massive logistical support. A single mile of interstate under construction might have 10 scrapers, 5 dozers, 8 haulers, 2 batch plants, a slip-form paver, graders, compactors, fuel trucks, water trucks, and support equipment. Every machine needed fuel, maintenance, and operators. Fuel consumption was staggering. A D9 dozer burned 8 gallons of diesel per hour. Run it 10 hours a day, and that's 80 gallons daily, 480 gallons per week, nearly 25,000 gallons per year per machine. Multiply that across thousands of machines, and fuel logistics became a major operation in itself. Maintenance was continuous. Equipment operating in dirt, dust, rocks, and mud required daily servicing, greasing fittings, changing filters, checking hydraulic fluid, inspecting tracks and tires. Every major equipment manufacturer established field service operations following interstate construction, sending mechanics and parts trucks to job sites. The interstate system transformed America in ways the 1956 Highway Act couldn't predict. Before interstates, a cross-country trip from New York to Los Angeles took 2 weeks of hard driving on 2-lane roads through every small town between coasts. U.S. Route 66, celebrated in song and story, was a 2-lane road with stoplights every few miles. After interstates, the same trip took 3 days on I-80 or I-40, driving 70 miles per hour with stops only for fuel and food. Freight tonnage shifted from rail to truck. In 1950, railroads moved 60% of intercity freight. By 1980, trucks moved 60%. Manufacturing decentralized from urban cores to suburban industrial parks accessible by interstate. Companies could locate factories anywhere there was an interstate interchange and draw workers from a 50-mile radius. American cities sprawled outward along interstate corridors. Suburban development followed the interstates, and were creating the metropolitan patterns we recognize today. The shopping mall, dependent on automobile access and parking lots larger than the stores themselves, became the commercial center of suburban America, killing downtown retail districts in cities across the country. The interstate system didn't just change transportation. It restructured the American economy, reshaped the American landscape, and redefined how Americans lived, worked, and moved. Every mile of interstate generated economic activity and development far beyond the pavement itself. If you want to understand how America was built, the machines, the engineering, the massive projects that created modern life, consider subscribing. There's so much history in the infrastructure we drive past every day without thinking about, but the machines that built it were temporary residents. As each interstate segment opened, the equipment moved to the next segment. Scrapers, dozers, haulers, pavers, all of it continuously advancing, following the construction front like a mechanical army. By 1992, when the last interstate segment opened in Los Angeles, the machine fleet had dispersed. Some equipment went to other highway projects. Some was sold to contractors working overseas. Some was simply worn out and scrapped. The machines that built the interstate highway system no longer exist as a coordinated fleet. What remains is the road itself. You can still see evidence of the construction methods. Interstate embankments show the horizontal lifts where scrapers deposited earth in 12-inch layers, each layer compacted before the next was placed. Multi-concrete joints every 15 feet mark where slip-form pavers stopped at the end of each day's pour. Rest areas and interchanges occupy sites where concrete batch plants once operated. The interstate right-of-way is typically 150 feet wide, the minimum needed for construction equipment to work efficiently while traffic continued on adjacent lanes. The road is a physical record of the machines that built it. The engineering standards established for the interstate system became the template for modern highway design worldwide. The grade limits, curve radii, lane widths, and site distances specified in the 1956 Highway Act are still used today. The machines evolved. Modern scrapers move 60 cubic yards, dozers produce 400 horsepower, slip-form pavers are GPS guided, but the fundamental methods remain unchanged. You still clear with dozers, move earth with scrapers, haul with off-highway trucks, pour concrete with slip-form pavers. The interstate highway system proved these methods worked at continental scale. Dwight Eisenhower, who championed the interstate system as president, never lived to see it completed. He died in 1969, 23 years before the final segment opened. But his vision, inspired by the Autobahn and informed by his 1919 cross-country convoy, became reality because engineers solved the earth-moving problem. The machines that built the interstate highway system represent American industrial capability at its peak. They were crude, dangerous, powerful, and effective. They moved 46 billion cubic yards of earth in 35 years. They built the physical infrastructure that defines modern America. And they did it by combining simple mechanical principles with massive scale and relentless forward momentum. The interstate highway system exists because someone figured out how to move 1 billion cubic yards of earth per year, every year, for decades. That required machines that didn't exist in 1956. It required operators willing to work brutal hours in dangerous conditions. It required contractors who understood logistics as well as construction, and it required a national commitment to infrastructure that seems almost incomprehensible today. The machines are gone. The operators are retired or dead. The contractors have moved on to other projects. What remains is 46,876 miles of concrete and asphalt, traveled by 300 million Americans who never think about the machines that built it.